All right, hello, hello. Hello, hello. We are live. I'm going to undo my text here again. So that we don't fool anyone. And we have at least Lucas in the stream. Hello, hello. And maybe someone else. That's cool. Welcome, welcome. So today we're gonna continue with sort of similar things that we did last time with these interaction areas. But we're gonna focus on vehicle switching today. I need to get that feature done so that I can prototype some gameplay scenarios here. And yeah, I'm trying a slightly different microphone setup today. Trying to minimize the amount of like heavy breathing and speaking really closely to the microphone. So let me know if the volumes are too low or something. Or if you can hear me just fine. Anyway, today we're gonna probably concentrate on programming again. I've prepared hopefully a little better than I did last time we did programming on stream. That was kind of chaotic. And we'll see where that takes us. But this is completely unrehearsed, so there's bound to be a little bit of messing around. Let's see what we have currently. I worked on the interaction areas quite a bit lately. And today we're probably just going to go in and just basically break everything again. Here we have an interaction area, which we can enter. We get this nice little prompt on the screen here. We also now handle all kinds of weird things where we like spawn a vehicle inside of it, and then we set that as the avatar, and it handles these kinds of things now properly. If we actually interact with this area, we can see here that we now got like player 1 on the road. That's just something that the area is scripted to tell us. That we can essentially script them to do anything. This one, on the other hand, if we interact with this, it says player 1 on the slope, and then it disables it. So you can see this sort of faint outline of the area still. It's still there. It's just disabled. Actually, the other one is there as well. It's just hidden. We can get them back by resetting like the road one. We get it back like this, and we can reset this again. Where was it? Reset slope. So that's pretty cool because with this now I can essentially script these areas to do anything. But the problem is that if we have the system like this, where you can interact with something, and at the same time you're close to this other vehicle, and you want to switch to that other vehicle, now we have like two things theoretically sort of trying to get your attention. And at least my initial design for this is that vehicles should override. They should take preference over the areas, because like now if we interacted, we would probably actually switch to this other vehicle like this, because then you can drive this thing away. But like, how do you get to that then? Then you have to do like weird switching like this. I don't know. Maybe we'll have to actually support sort of primary and secondary. So you can actually get like two prompts. You know, press E to interact with the area, press F to switch vehicles or something. I don't know. For me, the sound level is all right. Good. Let me know if that changes. Like if I if I change like position or something. Yes. Anyway, the vehicle switching is supposed to work kind of like how it did in Project Slide, in the previous project. Basically, like if you have a car in the world, it's not currently in use by like a hostile faction. So basically, like the enemies. This game doesn't really have enemies. At least I haven't really planned for that. It might have. I might have some vehicles that are controlled by someone that you can switch to. But in Slide, the rules were such that if your velocity is low enough and you are close enough to another vehicle, that vehicle's velocity is also low enough, and it is a so-called friendly vehicle, then you can just switch to it like this, back and forth, and do things. And with this, we will also have this thing which I mentioned last time. If we spawn the big mother vehicle here, and the mother vehicle is like a little ways off, you should be able to use the crane as well to sort of reach the vehicle that you want. And so this is sort of a special case. The crane needs to be adjusted. I can't reach very far with it currently. But of course, then you can lower the cable. And yeah, this should also work, I think, as sort of an extension of your reach. It's not really realistic necessarily, but I think it enables us to do some kind of interesting gameplay things. So that could be kind of fun. For today's work, I wrote a spec. A specification. Here's my spec. This is Checkvist. This is like a browser-based outlining tool thingy, which I use to do all kinds of things. You can like blah, sub, blah, and then you can mark things done, etc. So it's probably not going to cover everything, but it covers a good deal, I think, of things. And this also probably means that we're gonna have to break what I've just made. Just mess with the stuff that's already there. Can't be helped because this like vehicle switching and the interaction areas are sort of using the same systems to a pretty large degree. So that's that. I think there was supposed to be like a new SIG version tag today, right? Like if we go to SIG, issues, and then milestones, right here. Yeah, so this is due by today. But they still have 39 open. So it's probably gonna get postponed, I guess. It doesn't really matter. I'm using a SIG version currently that's probably around like a month old or something, so I'm pretty close to the master, but not quite. Not quite there. Okay. I'm not gonna do any upgrades or anything like that today, though. But let's see what we did. So we have a previous version. Traction point is obviously written in SIG, if that's not clear to anyone yet. We have this interaction manager that we've worked with in previous streams and videos quite a bit. There's also an interaction manager from the previous project Slide, which was written in C++. So, come on. Looks like this. This basically handles only the vehicle switching I never really got to the interaction areas in Project Slide. And you can see that there were some other things here, like attaching and detaching trailers. These things actually did work, or they do work in Project Slide, but they were never actually implemented using the interaction manager. But we might actually take some things from this. That's pretty good. Anyway. Let's get started with the actual work. I'm gonna drag my spec off here to the side. So interaction manager. This has grown quite a bit since we looked at it last time, because we do indeed handle all of those weird edge cases that I listed previously. But let's not make that discourage us from actually messing around with this thing. So the first thing that I have here on my spec is the interaction type. So whenever an avatar object, so basically like the player's vehicle, enters an area, an interaction area, and there's interaction type here, which we're going to set to 2. So an interaction type will be something like switch vehicle or interact with area, something like that. So now that we want the system to handle both of those cases, we'll want to add an enum for that. So let's do that. We have here already interaction area state. This is a relatively new enum. We already saw like active is the yellow flashing one, inactive is the barely visible one, and then hidden is hidden, obviously. So interaction type. And let's call this probably like interaction area is like 0, because that's essentially what we've had previously. And then switch, oh no, not that kind of switch. Switch vehicle. It's like the next one. That kind of stuff. We have the interaction things here grouped. Yeah. I do wonder, by the way, if we had the problem with the autofix not really working previously. So if I do like make a function here, let's call that self, like this, and do void. Now if I save, yeah, it's still not actually adding the autofix there. I wonder what's wrong with this particular machine. Like now if I try to build this, I get an error about an unused function parameter. That's so very weird that I don't get those. Basically what it should do is it should like do like self, and then it should write autofix here, like that. And now if I call this destroy, for example, and I save, it should remove that because it has this autofix comment here. Oh well, probably gonna have to reinstall Zig on this machine soon, but we'll make do with what we have. Here we have an autofix. I bet it was added by my other machine, which I do like most of my development on. But okay, let's keep going. Right, so the next thing here on my list is this. Yeah, we're not in there actually. We're in here, interaction manager. Next thing on my list is this player data's array list. So player data has the host ID, which is sort of like the unique number for the player, because at least in theory this supports multiplayer. And the avatar name hash, that's just like the string hash of the name of the object. So the car or the vehicle that they're driving in. And this is stored in a list. So we have player data. We initialize it there. And we react to some messages that are sent by the engine, such as when an avatar is sent for, like that object is now the avatar for that player. So player with this host ID, this is where we actually push those datas. And I think we will want to change that actually. We want to change it so that we populate that list of player data when the game starts. If we have more players joining than later on or leaving, we can modify it like after the fact. But there is a message, and these engine level messages you currently have to go like into the C++ side to actually get a list of. We have engine messages here. So game started is sent and game ended. And so those are essentially like the two ones that we will want to listen to. They are in the message category game flow. So we can subscribe to that message category. First of all, message node. This node, subscribe to message category, basis engine messages, message category, game. Oh, we do actually do that already. Yeah, I should have looked at this earlier. These are, by the way, these are just brought in directly from the header file by Zig. So Zig can actually read header files. Look at this header file again. This essentially just contains two enums, nothing else, no C++ code or anything like that. That means that Zig can actually read this. They end up in a somewhat difficult to read format though, which I currently can't actually see for some reason. Like it should be here in the Zig cache. Let's see if we do like, oh, it's probably because I have this broken build here. Let's build this properly. And I think we should be able to see that. I'm gonna clear my Zig cache completely and build it. Let's see what we get. Yeah. My Zig integration into Visual Studio Code seems to be a little broken currently here. That's unfortunate. But I'm gonna waste time fixing it here on stream. I'll do it off stream at some point. But if we look at basis Zig, this is actually how we import that stuff. This is really cool. If you happen to have C code that you want to use. So we take basis engine messages.h, which is this thing here. And you put it into an engine underscore messages namespace, or what do we want to call these things? And then you can just use them like this, engine messages. So let's do that. Let's listen to these new messages that I talked about. So we have message game started. Right. Put a comment there so that it doesn't fold that line up. Same thing with message game ended. Yeah, it does that if I don't put in like a comment here. Like that. And we can look at how we actually want those to be filled in here in this on the C++ side. Actually listen to the same things here. So if we are not on the client, because this sort of only concerns the server side, we get the session, we get the player count. This is just a vector, but I actually want to keep them in a hash map on the SIG side because I realized that there's a lot of looking up by host ID, so let's just put them in a hash map. And they're called interaction states here on the C++ side, but we'll use the player data struct for this. So let's see. Yeah. Right, so we have the host ID here currently. We will not have that there probably because it will be in the key, or we can keep it there as well. I don't know if that makes any sense. I don't think we need the last known positions. We can take that away. But let's see where we use this currently. So we have it. We initialize it here. Then we have the set avatar. We won't want to actually poke at that right now. And the clear avatar in the on player interaction input. So this is called when someone actually like presses the E key currently. Right. And when the state changes. Okay. Host ID from avatar. Okay, well that one we can probably just delete right away. Yeah. Maybe we'll keep it for now. Let's start with something else actually, because this is sort of like this is just ripping out the guts of this struct completely. And then we won't have anything building. Let's start with something, approach this from a slightly different perspective. This object in area is going to go away, and we will replace it with something called a vehicle, quite simply. Vehicle struct. Because vehicles are very sort of important to this whole interaction system. The vehicle struct will have the object name hash. It will have a pointer to game unit component. This is something a concept I've taken from slide. We don't have the game unit component yet, so we'll need to create that. I'll put in a comment here. Game unit pointer. We want the player host ID. And we want the area. The area is going to be an optional pointer to an interaction area component, like so. So here we have this object in area. Like we created one of these guys whenever an object with this name hash entered this area. This is going to go away eventually. Instead we have this vehicle which has like an optional pointer to an area component. If the vehicle is not inside any of the areas, then this guy will be null. Otherwise it will be set and we can use it to do various things. Cool. And now because we are actually just adding this guy instead of like replacing everything that's already there, we can just start adding this in. So we will keep this in a hash map as well. So vehicles, let's do std auto hash map. Right, so this is object name hash as well. Let's sorry. Basis string hash. And we actually don't need the string there. And this can be vehicle. Right, so this is the name hash of the vehicle. I did put it there as well. It might be handy to have it here if we're going to iterate over the vehicles, which I bet we are. So let's keep it there too, at least for the time being. Then we can initialize this thing. And do we want to actually create like an alias for this type? I don't know. Oh, we want to init it, of course. Host allocator. Like so. We don't need to de-initialize it because we have this meta de-init members function, which is sort of, this is built from the thing that I made a video about recently, where we can actually, with comp time, little comp time programming, we can have Zig call the de-init stuff for us automatically. So we don't need to de-initialize it. Or we do, but it's happening automatically. Right. And then we need to register our vehicles somehow. And I think we have a component here called means vehicle component. So this is something that's added to all the vehicles in the game. Or basically, if you make a new vehicle, you should do that. Because this handles all kinds of things. And this is where we can actually register the vehicle with the interaction manager. I think I had something similar here actually, like slide vehicle component. It's like the same thing here on the C++ side. Yes. So if we are on the server and not in the editor, then we do like the interaction manager register vehicle. So it has the string hash, transform component, and game unit. Right, so this is game unit component. I talked about this earlier. Apparently it can be null here. The game unit component is the thing that essentially like determines which object is like friendly or hostile. And that's how it's been in the basis powered games so far. So let's use that. And I have quite a few of these sort of ideas that I think worked pretty well in slides. So I'm just basically almost like copy pasting them over. Except I can't copy paste because it's a different programming language, but still. So we're registering here in onObjectCreated, and we are unregistering them in destroy. And we have the same functions here. Means vehicle component, we have onObjectCreated, and we have destroy. So that's good. We can probably do, oh, I had some crap there. We can do self-context on server. And we want to unregister there. And here we have an on client, so we can just put in an else here. So register and unregister. And the registering, that actually wanted that game unit component. So let's create that now. So we call it game unit component. I have a snippet here to input like a Zig component for basis. Let's see if it's up to date, or at least up to date enough. You can do game unit component, and here we actually want to put in means as well. Right, and this guy doesn't really need to probably have all that much currently. If we can take that away, it doesn't need to tick, it doesn't need to update probably either. Eventually this guy will have some information about what kind of vehicle this is. And that will come probably from like blueprint properties. But right now we don't need to really care about that. What we can do though is go here into the vehicle blueprints. And this is the test vehicle, so if we click here, we won't see the vehicle as it is shown in the game with the wheels and everything, because those things are coming from like runtime things. But we have the blueprint for the vehicle here. Yeah, the scrolling is kind of not very good. Windows is erroring out. We have all of these components on the vehicle. We would want then to put in the game unit component here as well. So let's do that. Let's put in a component here. Let's call it just game unit. And it will complain that it doesn't know what that is because we just added it. We haven't even compiled, but that's fine. We can just go like, yes, yes. Believe me, it is there. Oh, yeah, this thing crashes because it actually uses the game to render this thing, but that's fine. It will still work. We can just shut that down. If we had actually built this, then it wouldn't have crashed. Okay, cool. So now we have the game unit component. We still need to actually hook it into the system. We need to make the engine aware of this thing. Like so, and then we need to put it into this tuple of component types right here. Like so. Yeah, this list then gets brought into the game. If we look at means here, oh sorry, it's main actually. We have these component types here, which is a bunch of lists that we concatenate. And there's an exported function because we're building a DLL here, which is then loaded by C++ code. And we feed this component types to the engine. And this list means component list. This is the one that we just added the game unit component to. So now it's sort of registered and ready to go. Duplicate switch value. Oh, so I was already actually listening to this guy here. That's silly. Then we can copy that. We can take those away. And just put them right next to each other. Yeah, I'm clearing the object in data here. Of course, that thing is going to go away, so it doesn't really matter. But yes, now it succeeded. So that's good. Okay. So now we have the game unit component, and we can access that via the means namespace, means.components. And we have the interaction manager. We have the interaction areas here. We have a register and unregister function here that I've actually left in here, even though they don't really do anything. But they might. So I've left them there for the time being. Turns out we don't need them, then I will remove them. But we can do pub fn register vehicle. We want the self. We want the object name hash, which is basis string hash. We want the game unit component if we have it. Like it can be this in slide. It was possible that it was null. That's kind of interesting, but I guess we want that support here as well. What was the other thing we had there? I think there was like a transform component. Let's see. Yeah, it passes the transform component. We don't really have transform components in Zig currently. We have a transform API, which you can access from any component. So we don't really need that, I would say. But let's do game unit. And we make it like an optional pointer then, I guess. To a means components, game unit component. Like so. We can shorten this a little bit. If we go up here and then just do const game unit component equals means components game unit component. And now we can take away this part. Oop. Yeah. Like that. And then we want the unregister register vehicle. Self. And I don't think we need anything except this, because that is essentially what identifies the object. Something like that. And that should allow us to like have the vehicles hook into this guy. So that they can be tracked where in the world they are, if they're standing next to each other, if they are moving or not, etc., etc. I'm getting some warnings here about like low bit rates. So let's hope that sort of sorts itself out. Might be that the internet is somehow in a bad shape here in our area currently. And let's see what happens. But in the meantime, let's keep going. And so we have this game unit component that we can now add here to our vehicle. Let's call this game unit. Optional pointer to a game unit component. But I think we will want to have like the vehicle, the means. It's called means vehicle. A non-optional component to a means vehicle component. So that would be means.components.means vehicle component, which again we can shorten like this. We will want to have some component that all vehicles have. And I think it means that is the component. And of course this is the thing that will actually do the registration and unregistration. So it sort of makes sense that all the vehicles need to have this this guy here. Right. So let's add that to the prototype. Like that. And I think that's probably what we want. And what we need. And now then in the means vehicle component, we can go in here and we are on the server because we do the check right there. So we don't need to do any further checks. We can simply do means server interaction manager unregister vehicle. And we want the object name hash. So the parent object, which we can get via the context. And then out of this guy we get the name hash. Or we can get the name as a string and then we can hash it ourselves. Whichever way we prefer. Same thing here. Context, yes, get game object. But here we need the game object for some other things as well. We need it for the game unit component. And so here we go via the parent object. We can go like, hey, give me the component with the type means components game unit component. And this will give us an optional game unit component. I can't select this thing here. But yes, this type here is an optional. So this is exactly what we want. And of course, we need the non-optional means vehicle component, but we actually do have that. It comes right here. So that should be pretty good. Victor says, hello there, first time seeing you live. I'm a game programmer as well, from France. 4 years as a generalist programmer in game from now. Cool. Welcome, welcome. What's your experience using SIG so far for gameplay code? Would you use it for engine as well if you could? Sure, yes. Sort of depends. I think SIG is probably quite flexible and performant, and at least in most cases ergonomic enough for engine programming as well. And especially if you're sort of in the indie scene, I think there's quite a bit of development going on with libraries and frameworks like Raylib and that kind of stuff. So if you're sort of building around that, then I think Zig would be a pretty nice option for you. I do use quite a few pieces of middleware, for example. As I've mentioned in previous streams and videos, I use, for example, PhysX, which is not super trivial to use via Zig. And I do that via my own sort of abstraction layers that I painstakingly make available via a C API. Because Zig interacts with C quite well, but not really C++. Of course, nothing really understands C++ except C++ itself, because like the ABI is not stable. But if you go via C, then you can essentially do anything. And yeah, I think Zig is probably good enough for a game engine. If you're interested, there is something going on called the Mac engine. So this is, as far as I know, still pretty early days, but they don't have like a whole tool set ready to go with like level editors and things like that, but they do have quite a few pieces of like the core engine running, and as far as I know, this is mostly written in Zig, if not completely written in Zig, actually. And the main developer is also a very, very nice guy to just talk to. Clearly super excited about what he does. So there are some things being built with Zig on like the engine level. As far as like gameplay code in Zig goes, it is mostly a nice and pleasant experience. I love the fact that you don't have to mess around with header files and you're using a proper module system. I do sort of miss things like operator overloading though. I'm using my own math classes, and you don't really need to do that if you use the built-in vector classes. Let's see if I can find the documentation here. Go to language reference for master. Search for vector. So at vector. And you can use these built-in vectors to do a lot. as far as I know, and they're also SIMD optimized. So it probably actually would make sense for me to like sooner or later move over to these guys. I have my own vector classes and matrix classes and related things that I use. I wrote them quite a few years ago when this part of SIG wasn't really stable, or at least very mature. And so I haven't switched to these, but these would give you like operations like this. So if we look at something like probably like some like camera code, for example, free camera vehicle camera controller. This has a lot of math and you need to like do the math via like member functions. What's some good? What is some good place to show you here? Here, for example, you have like sub instead of a minus. You have add instead of a plus. These kinds of things. Of course, like with floats and things like that, like the normal operators work. But that's like a little annoying. It would be like having watched and written and read C++ code for a number of years. Like proper operator overloading, it would be nice to have that stuff there. Right, you've written quite a lot and I've just rambled on. Yes, I have a C wrapper. Yeah, I have a sort of a code generation thingy that I use, which let's see if we can find the thing. So we have a bunch of libraries here. Some of them are like pure Zig libraries, like we have VHL, for example, Vehicle Helper Library. This is a pure Zig library. There's a bunch of things related to vehicles. Here's an automatic gearbox, for example, which, well, shifts gears quite simply. Then you have some things that are essentially the runtime is sort of written in C++. I just expose it to Zig, and with that I have this system that I call bind-a-lot, which is like has like a small exe and a DLL file here. And this is essentially like if you have a C++ class called effect instance, which we do. Let's see if we can find it. Merlin effect instance is right here. This is like a slightly larger on the C++ side. And Merlin is my node-based particle engine. But yes, you have this effect instance thing, and you want to actually like wrap that in Zig. How would you do that? Well, bind-a-lot helps you out in the sense that you can write this bind-a-lot file, which looks almost like C++, but it's not C++. These are sort of like C functions. They're wrapped in something called a class, but you can just it's not really like a C++ class necessarily. It can be just a selection of global functions like this. And then you need to handle this pointers with like a uint pointer like this. And you write your methods that you want to bind. So if you want to call like, you know, start on the thing, and it has like a start method here. Obviously this handles this pointer like implicitly, but here you need to pass it explicitly. And then you run bind-a-lot on this file, and it generates a whole bunch of function pointers for you. So if you go and have a look at what the effect instance looks like here in Zig, I have sort of a convention here that anything that is actually just wrapping a pointer on the C++ side ends with like ptr, like this. And you have the start function here, which looks like this, a normal Zig function. Sort of just trying to make this as ergonomic as possible from the Zig side. and then just calls into merlin.bindings.fp stands for function pointer, and then has this effect instance. And if we have a look at this, this is like the generated by Sir Bindelot, and it generates a whole bunch of, well, it generates like the actual instances of the function pointers, but then if you go here, it actually generates the function pointers to, etc., etc. And then on the C++ side, it generates even more things. See if we can find the Merlin side here on the C++ side. So we have Merlin Zig interop here, and here we have the Merlin generated class bindings. So we can find the same thing here somewhere. There it is. Basis Sig effect instance start CB stands for callback, and yeah, this is all also generated. So essentially, you just need to write like you need to write this part, which wraps it in like a nice Sig function for you, and then calls the thing, and then on the C++ side you need to unwrap it and call the actual effect instance thingy. So yeah, there's a whole thing. There's a whole sort of process of binding like this. It's not necessarily like the most efficient way of doing it, and it uses a bunch of function pointers, but it does give you the option to use C++ from Sig as if it was kind of like a Zig object with member functions and things like that. And like the basis API, before I started wrapping and exposing things to Sig, I had the basis API, C++ API, and it tends to be kind of object oriented. So I sort of painted myself into a corner there with doing it in an object oriented fashion, but oh well, it works quite all right. Yes, C is definitely easier to use. And yes, I don't know if you were here a minute ago when I actually showed that we are in fact passing some headers from the C++ side to Sig. Where is it? It's in basis.sig actually, like right here. Engine messages, we just pass this basis engine messages.h, and C import and C include takes care of generating. It's not like just magically appearing there, but actually if you take a look in your Zig cache, which is generated every time you build your Zig code, you can see that it has actually generated like a Zig file with the same things as we have in this header. But yes, that is a much easier way to go if you're sort of comfortable working with a C code base and you just want to wrap some things and use them from Sig. That's typically quite easy. I was sitting on a huge C++ code base and I wanted to use that from Sig, and that was more tricky. Do you know if it's easy to add some hot reload capabilities in Sig? Reloading DLLs and stuff like that. They are working on like official hot reloading support for Sig. So I think it was in the last status update video that Andrew Kelly made. He spoke about the fact that they've rewritten the internals of the compiler in many cases to avoid pointers and use lists with indices instead. And the idea there is that they can just replace contents without having to do any like pointer fix-ups or anything like that. And the end goal is to be able to hot update code. But of course, you can, if you want to, you can do hot reloading with DLLs. That's not really dependent on the programming language at all. And of course, in my case, I am actually making a DLL. I'm building this thing into a DLL here, which is then consumed by the game engine. But yeah, hot updating code is not something that I do currently. Let's see what else. Blah, 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 blah. What made you get SIG to handle gameplay code? Aren't you afraid that when release 1.0 will come, the language will change quite a lot? Does my game target PC only? I've used SIG since 2019, I think, now. And it has changed quite a lot. They have been pretty good about helping you out with updates, though, or upgrades. So in many cases, if you just update your SIG compiler and you try to build the game and you get like 100 error messages because something has changed, in many cases it's just been a case of like going into each of those files and saving them, making sure that you have the SIG formatting enabled. It's basically the same thing, which does like, if I save this, nothing happens, but if I put a comma there and then I save this, it formats it vertically. So that's a SIG formatter. And it has some upgrade paths taking care of some things that are known to have been like breaking changes. It fixes those up. Not always though, but in many cases that's actually been the case. But yes, things have changed for sure. For example, they changed the the function pointer syntax at one point, and as you can imagine, with all of these generated function pointers, it was a lot of I got a lot of errors. But of course, since I generate this code, I just went into the generator and just fixed it there, and then I just regenerated everything, and it worked. And it might change still, sure. I am targeting PC mainly. The game did run on the Mac last time I tried, but that was a while ago, and I know for a fact that the Metal renderer doesn't actually even compile currently, or build. Might work with Web GPU though. I haven't tried. But yeah, the SIG side hasn't really been a problem with the Mac at least, and on Linux I don't really know. It probably will. Like the core engine compiles on Linux at least, and with the Web GPU work that I did last year, I assume it would probably work, but yeah, haven't tried. What else? Are there any helpers relative to SIG? For example, get directly the entire module pointer symbol from DLL. So, like, if you're building a DLL, one thing to realize is that it uses the C ABI, so you get the symbols exactly the same as you do if you were writing C. As far as I know, there is no stable SIG ABI. So if you want like two pre-compiled modules to talk to each other, you're using the C ABI for that. So basically, it works the same way there, as far as I know. They might be working on some other things, but so far that is the case. Blah, blah, blah. Speaking of SIG cache, it's one of the greatest features I like, and it's that reason SIG CC as a compiler. Yeah, I haven't actually used SIG CC because, well, I don't really use C. I mostly compile with MSVC or with just Apple's Clang if I build the actual engine. But yeah, I hear it's actually really, really nice. yeah, I would say like one of my main gripes with Zig currently is like the build performance. If we remove the cache here and we build the debug version, you can see here how long that takes. It doesn't take all that long to do a complete build. Oh, I've been messing around here with things. Should get back to working at some point, but this is interesting to talk about. So I don't mind. Yeah, so let's see. Doing a full build. How long does that take? Not very long. I have more things that I probably broke. Oh. Yeah. Yeah, this is annoying. It is annoying, but it's not really Zig's fault. It's my visual or VS Code setup is somehow broken, at least a little bit. It should really add those automatically. But yes, my main gripe is with the release compile speed currently. Okay, so now we know that this actually builds. Let's see, like if I now build there, how long does it take to build a full build? A few seconds, I would gather. Like, yes, now it's done. So that took like, I don't know, 7-8 seconds maybe. And we're building a debug version. Now if we just to be sure here, we're deleting the cache and then we're building a release version. I bet this will take ages, at least comparatively. And I, as I understand it, a lot of the time here actually goes into LLVM, which they are of course trying to get rid of. But in my case, it's not that bad because gameplay code isn't really usually the thing that eats up the most performance. So what I can do, since this is using actually like CABI, so there we go, now it's done. That took like probably 4 times as long or something. Anyway, I'm using the CABI here, so I can, without any problems, I can use a release version of the engine, and then I can pair it with a debug version of the gameplay code, which is nice in several ways because I can build relatively quickly with good performance still because the engine is running in release, and I also get all kinds of runtime checks and nice error messages if I leak memory or I go like out of bounds or something. Out of bounds is not terribly easy to do with Zig, but you can do that. Things like that. What about your experience to debug using only VS Code? Yeah, debugging is not super nice currently. I've had some discussions about that on the Zig Discord actually recently with someone, I don't remember who exactly, but our experience was similar. So I can debug depending on what I want to do with any debugger that supports PDBs. So if you have this C++ extension installed in VS Code, I can debug here. That works fine. Let's see if we do something like that. What should we do? Let's put a breakpoint here in the interaction manager in object entered interaction area, for example, and you will see that it's not super nice currently, and it depends on actually what you do. If we drive into this area, we should hit that breakpoint. Like boom, there we go. And you can see here that okay. Yeah, there are a lot of question marks here. This is an debug. I should remind you that this is actually debug code here. So yeah, a lot of this stuff is not really easy to read. But I mean, we can read the host ID, we can read the name hash, this boolean here. Of course, a lot of this is just the fact that we are using a C debugger to debug Zig code. So I don't really know what to sort of expect of it. If we go into player data, we can see that the capacity is 8. It sort of makes sense, but it's not super nice. It's not super nice. These channel IDs and listeners, they look correct as well. Target host ID -2 is probably correct as well. So it does kind of work, and you can step through this and move forward, and it basically works. And you get the call stacks and everything. Whoop. But of course, as soon as you step into like C code, so here we are inside physics actually. Typically, these things make a lot more sense because now it is like, this is C. I know this. I know this stuff. So you can see here means game.dll. This is the Zig DLL that we are stepping into. And here we are in physics. Oh, that's actually not physics. This is basis physics. So this is my wrapper around physics. Yeah, I thought that code looked familiar. Yeah, we're not actually inside physics here. We're stepping right past that. But here we are in the core engine, and you can see typically things make more sense here, and you can go into these and they show much nicer information to you. So debugging is not like super easy currently. Choosing PDB, you can do it directly with Zig language. I don't use it in Visual Studio as well. Yes, you can debug it in Visual Studio as well. That works perfectly fine. If we go to, yeah, there's the stop button. Yeah, we can go here. I don't know, do I have any Zig code here? I probably don't. But yes, you can definitely debug it with this, and it shows like slightly different values occasionally. Like the debuggers are clearly not the same because they work kind of similarly, but still not. And then of course we have remedy BG, which is this pretty interesting debugger thingy made by one person who has done some wonderful work in certain areas, but then other things don't really work all that well. Let's see. If we go into, where is it? Gameplay. Interaction Manager. We can put a breakpoint in the same place here, for example. And then we run this. Let's see. Blah, 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 blah. All right, that's debug. Let's run the release. And we get the menu, so let's just skip right past that and go into the level. Now if I drive into the same area, it should stop there as well, like this. And here you can typically see like slightly different things. And yeah, I guess these probably are quite accurate currently, actually. So it's okay. It's okay. Interaction type is 0, yeah, because we just set it to 0. And Rad, which is of course nowadays part of Epic Games, they are also working on their own debugger, which is supposed to be somewhat usable with Zig. I haven't tried it myself, but there's this Rad debugger project, which also uses PDBs. And oh, you just mentioned it. Yeah, the new Rad debugger seems nice. Yes, it it does seem nice. Yeah, there were some people on the Zig Discord who had success with that, but then it like some version started crashing or something. I don't know. But yes, I typically I jump between Visual Studio Code and VS proper for these kinds of things. But currently you still have to do a fair bit of printf debugging There's no real way around that currently. It's not that nice, but I expect it to be better with time. C++ debugging experience, yes. But worse because it's not SIG syntax, yes. Indeed. It's not SIG syntax, and sometimes like the debugger jumps to some place where you're like stepping forward. It jumps to like some place that you're not quite expecting. And of course, if you're if you want to be really confused, you can try debugging comp time stuff, and then that's just all bets are off. That's typically completely crazy. But that's to be expected because the comp time stuff like generates code that's not really the same same thing that you see in the source file. Yeah, I did open quite a lot of files here that I'm not currently interested in. Okay, cool. Good questions. Fortunately, I wasn't able to answer all of them. But my overall feeling is that it's not super good, but it's getting better all the time. And like a year or two ago, the Zig language server was just crashing basically every 10 minutes or so, and I used that for like a year or two. Sea Lion, yes. Yeah, I used Sea Lion for about a year, I think. It was around the time I ported this core engine to Mac. I used Sea Lion for that. And then for some reason, I think it was something to do with PhysX requiring like VS19 2019 or something like that, and then I had to upgrade the compiler to build that, and then I sort of, for some reason, I didn't continue, and then my license expired and blah blah blah. But yeah, it's quite nice, and I like the IntelliSense or the IntelliJ based IDEs have the best version control interface in my opinion. I want that. I want that in my. Want that as like a standalone tool. But yes, I do have an old C-Line license that I've used a couple of years ago quite a lot. Okay, let's keep going with this the stuff that we were actually doing. I think I was about to register the vehicle here. And like, just if you have any more questions, just keep them coming. I don't mind. I don't mind. In the meantime, let's do a little bit of work. So let's register the thing here. So now we have the parent object, and we have an optional game unit component. So let's do parent. Oh no, sorry. Yes, parent object get name hash means vehicle is self and game unit is game unit. And I think I better clear the cache here just in case. One thing I should mention actually that's like really nice about SIG is the build system. And I mean, anything is nice compared to C and C++ build systems and CMake and everything, you know, that's kind of horrible. But the fact that you can just build things, you can set up your build script with SIG itself is just so very nice. So here's the build script for means currently. And this is sort of a weird version of SIG because this is kind of declarative, if I understand correctly how this is actually working, and then like memory management is kind of a little different in this build script version of Zig. But any Zig that I've thrown at this, as far as I've used it, has worked just like I expect it to work. But as far as I know, it's not exactly standard Zig. Because this, of course, doesn't really get compiled. It's sort of like interpreted almost like. But yes, so here's this shared library. So we're producing a DLL. We call it means game. All right, here we have actually a flag like this is the thing that I'm currently using. Use debug lib with release game. It's just a Boolean constant here because it's faster to build, etc. And then we have the modules. The modules are here. We create the modules that we need, the libraries, and then we have the imports here with some specific name. So we have the core library, we have trampoline, which is like the exe essentially. It provides some functionality. Goofy is the UI module, Timbre is the audio module, Nemo is like the scripting thingy, Merlin is the particle engine, and then we have these helper libraries that we looked at earlier, and it's all just Zig. It's nice, and you can create your own helper functions here and then just build everything. But of course, you know this if you've actually used ZigCC to build things. But this is really, as far as I'm concerned, this is sort of like a selling point for Zig, because this is like cross-platform and it just works. You don't have to mess around with like any horrible CMake scripts. And they are horrible. Like if we look at the core engine CMake script here, for example, it's just like bleh, this horrible language that like some sort of weird state machine. And uses like some very confusing syntax to define things in various configurations. Yeah, much prefers Zig. So if I'm correct, so far your engine is C++ tools, C#, and gameplay logic is in Zig. Yes, pretty much. There's some tools in C++ as well. Those that require the engine to be running. Actually, that's not even really all of them. There's Timbre, for example. So this thing here. Oh, I don't have a project set up for this. This is the audio engine. And where can I find my Timbre project? Audio means Timbre project is right there. So this thing is written in C#, but it does use the engine, the runtime engine, to actually play back these things. I don't know, like how. If we put the events there. I haven't used this on this machine clearly because this UI is not set up how I expect it to. But yeah, you have like an engine sound, for example. See if I can I mix this into the stream? I think you should be able to hear that. And you can like adjust the RPM like this. And it mixes all of these wave assets together with curves like this, and it does run the C++ basis core engine there, because it uses that for all kinds of like threading and serialization and well, interfacing with the audio system. But most of the tools are C#, and most of them are only C#. Then we have some of these converters that are triggered for, like material converter is right here. That's C++. Mesh converter is right there, etc. So some of them are C++. Most of them are C#. yeah, C-line memory consumption is quite well, quite bad actually. But I do remember it being perhaps even a little faster than Visual Studio, because the Visual Studio just tends to get very slow when you have lots of projects. Here we have like, what is this? 20, 30 projects. This is not that much. The tool solution has even more, and it is just really slow. Did you ever try creating your own GUI lib to create tools? Yes, ImGUI is used pretty much everywhere, including my game. Oh, running slide now. Let's not do that. I do use ImGUI here as well. Of course, this is not really what you asked. You asked if I tried to create any like tools with this. No, I haven't done that, but I've used ImGUI as sort of debug menus in various companies, and it's kind of an interesting prospect to build like a cross-platform application using ImGUI as the UI layer for that. So yes, in that sense, it's probably quite a sensible choice actually. Did you create your own GUI lib? Well, I do have my own GUI system, which is called Goofy, and it's rendering all of these things, like this menu here, for example, is and all of these animations and everything. Oh, let's turn down the volume a little bit. And this is all custom stuff, custom animations and everything like that. But it's not really a application UI library, of course. Looking at CMake, I'm sure that C++ programmers like to overcomplicate their lives. Shame there's no better solution for now. There is actually sort of a better solution than CMake, if you really want to. If you really want to generate your C++ solutions, but you don't want to use CMake. SharpMake is actually developed by Ubisoft, and this uses C#. So at least the language is nicer than CMake's pseudo language. I don't even know what to call that. There's a whole wiki here if you want to have like a simple library tutorial. This is sort of how the scripts look like. So add targets with like nice, easy to understand code. SharpMake is quite awful. Trust me, I worked on Rayman Mini. Yeah. I do trust you. It's just that the company that I work for uses this with like, I don't know, we have probably like 350 solutions or something building for like 5 or 6 platforms. It works great. I wasn't the person to actually implement it though. I've just used it, so it might be kind of horrible to use. I will say that CMake is pretty nice once you actually have it set up, right? Like if you do the initial hurdle of setting it up, which is kind of horrible, it's pretty nice to actually use if you have something that you want to add things to. Like here's the trampoline. This is like a small exe file that kicks off the SIG code. And once you have this thing set up and you have these files here, they can add and remove and all of that. it's going to be easy to use, and Visual Studio even works quite well with CMake these days. And I sort of get the same feeling from SharpMake. But yeah, Premake might be a nice alternative as well. You can go quite far in UI with ImGUI. The nice thing is that if your engine code is in C++, everything is in C++, no C# or heavy Qt stuff. Indeed. That is absolutely true. Adding platforms in SharpMake is not really an enjoyable experience. Yeah, I can imagine. Like I said, I wasn't the one to set that up, but we do use it, and it works quite well when once it is set up. Okay, cool. Where was I? See if this builds. Okay, it does build. So now we are registering right here, and we're unregistering right there. That's good. I think if we go into the asset browser, I think all of our vehicles that we have so far have the means vehicle component. So we have one there. We also have one in the test vehicle. We have one there. And we have one in the mother vehicle as well. Yes. Good. So we only have the game unit component for the test vehicle currently, but that is the optional one. So that's fine. And now then, let me look at my notes again here. So register vehicle, we probably actually want to have this handle errors, which you do by adding a question mark there, and ideally you specify the errors you want to handle. But if you don't, you just specify the question mark, they are inferred, which makes some things trickier, but most of the time it works quite well. Because now what we want to do is we want to create a vehicle out of these things, and we call it object name hash would be object name hash host ID. Host ID is going to be basis network. I think we had a unset host ID because it's not anyone's avatar yet. What's the order of this, by the way? Object name hash means vehicle game unit host ID and then area. Game unit is quite simply game unit, which may or may not be actually set. Yeah, area can also be optional, and it will be in the beginning. Means vehicle needs to be set. Means vehicle. I might have an older version of the language server here because it quite often fails to give me something. So if I do like const test one to have something. Yeah, now it can give that, but sometimes it doesn't. It's kind of strange. Did you ever write code using SIMD or OpenMB equivalent in Zig? Are the language primitives for that? Oh, don't worry about the interruptions. This is sort of a laid back part of my day. Yeah, like I mentioned I don't know if I talked to you about it. I think you were on the stream when I talked about this. We have the vectors. These, as far as I know, try to use SIMD code if they can. But I haven't actually tried these out. I haven't used these built-in vectors at all. But they're supposed to be like the most efficient way of doing matrix multiplications and things like that these days. And yeah, that's the only part of the language ref that mentions SIMD these days. This is, by the way, like the very best place to learn SIG if you want to. Like you go to ziglang, ziglang.org, and then learn, and then depending on what version you have, but typically, or at least at this point, you typically want to use master. Then you just go to the master one and language reference. And then here, this is all just like one big, huge document. You can just search in here. You want something like, I don't know, slice, for example. And you can find it here on this side, and then it just highlights everything for you. It's very nice. Doesn't SIG math library use SIMD internally? Yeah. Exactly. And there's something called CMath, right? Isn't there? I think it's called ZMath. So, yeah. It's a gamedev project. So here we have ZMath, CMD math library for game developers, which I also have not used. But this sounds like what you want if you want to do CMD math in Zig. And this is pretty well updated 3 days ago, 4,000 commits. So probably worth looking at that. But yes, examples are easily accessible. Another killer feature of SIG is the standard library and the unit tests. First of all, the standard library is like the code is super easily readable. Like if you go into what should we go into? Let's go into the interaction manager here in C. I mean, I'm sure you know this, but still, if you go into like vector, and then go into std vector, and then you try to read this stuff, and you're like, oh my god, what the fuck is going on here? And it's like, well, this is not even the the worst offender, but like, this code looks like I don't even know. And then you go and compare that to like the array list in Zig. Here, and everything is just super nicely commented and very nicely, like clearly written by hand by someone who cares. And then you're like, okay, so how do I use ensure unused capacity? Then you just search for that thing here in this file, and at the bottom you have a bunch of unit tests. These are all unit tests, and you can just see here that okay, well, yeah, maybe that function wasn't like the most the most easily explainable. But anyway, like basically like almost half of this file is just unit tests. So you can see here's how you initialize like an unmanaged thing. And this goes for a pretty sizable portion of the standard library. It's just nicely written, and then it ends with unit tests showing you how to use them. So that's nice, especially for the standard library stuff. EASDL, yeah. I don't think I've ever actually used EASDL. It's been around forever. Right. Right. Okay. Cool. So now we want to push this to. So we have the vehicles, yes. And this is like put is the one we want. It does throw errors though, so we're gonna have to try to use it. And we try to use it by just adding try in front of the call, and then what was it? Was it key first and then value? So I think the key was supposed to be object name hash, and then the vehicle is the value. And of course we can just basically take this guy and add it there. That should be fine, and then we need to basically take out all of those. Error is ignored. Yeah, so this thing now needs to. That's probably the registration, right? No, it's not. It's that. We need to try to register, and we also need to try to unregister. Yes. And if we are unregistering, then I don't really think we actually need to try that. I think we can just erase them from the thing. I can't remember was it remove? Yes, it was remove. And it just returns a boolean whether or not it was actually found, but well, that's fine. Yeah, so that doesn't need to be actually a try, but we can leave it there for now. Doesn't matter. And take those away. All right. Yeah, so these kinds of things are like a little annoying in Zig that can't ignore anything. They've saved me once or twice when I've clearly done something wrong. Like I misspelled something and it goes like, oh, you didn't use this. But in many cases, like you just want to remove something, you don't want to care about that. Okay. So now we're adding and we're removing the vehicles. Yeah, I'm not gonna I'm not gonna get this vehicle switching working today clearly, but it doesn't matter. This was a nice conversation that we had. Right, I'm just looking at my notes here. What the next thing would be? Blah, 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 blah. Yeah. Treat all the client proxies. Yeah, so we will need to have a tick function in this struct. Where should we put the tick function? There's the D in it. I think I typically put it next to those. So the initializing and deinitializing functions there. So we can do like a tick, fn tick, and I don't think we need any sort of delta time. But do we still typically take like a tick delta? Tick delta time, F32. That just means I'm gonna have to actually ignore it. And of course the self is important. Yeah, I don't know if I need the tick delta time, but let's have it there for now. And then we go into the means app. And this is where we can find the server tick. On server created, before server destroyed, on client tick, on server tick. So here we go. Means server campaign manager tick. Why don't you see the tick thingy? Oh, not campaign manager. Sorry, that's interaction manager. Tick. There we go. Yeah, we have the tick delta time there. On this, we'll for sure need to catch errors. And here we have another thing that is a little annoying. This won't work. We can't do try here. Because this on-server tick is actually called by C++ code. And C++ or C, it's not called by C++ via a C layer. C doesn't know anything about the SIG error handling. Interestingly, that did actually build. How is that possible? That shouldn't be possible. That's really strange, actually. Shouldn't be able to call try on something that doesn't have like an exclamation mark there. Is this thing actually even called on server tick? I think that's part of the V table that we have. Yes, that we're in the app interface. Okay, I'm kind of stumped here, but this thing now, this has an exclamation point there. Now if we try to build this, now at least it should fail, because it goes like, oh, error is ignored. I'm not exactly sure what happens now if I use the try there. But what I typically do when I get to this sort of border between C code and the SIG code is that I catch the error at this point before it reaches the C++ side. Like this, and I need to put a semicolon there, and then I do like basis fatal error with name. You can add like a source location there, so that it can give you the line number and everything, and then you just pass the error like this. So that means that it doesn't try to like forward the error at this point. If we get any error in the tick for the server interaction manager, sorry, you just get an error message there because it's probably a fatal error at that point. Thank you for the chat. That was really nice. I need to go. Thank you for your time. Have a nice live stream. Thank you as well. It was nice to chat. And I'm probably gonna end this live stream pretty soon. But yes, thank you. Have a good one. Cool. Let's add the client, and again, not campaign manager, which it wants to suggest to me, but the interaction manager. Tick delta time, catch, and catch the error there as well. Like so. Yeah. Yeah, trying here in this is I'm kind of stumped actually. Shouldn't work, as far as I know. Let's try somewhere else. Did we find like a bug in Zig here now, or is this something different? Vehicle description reloaded. Right, this is a function. It is called from several places. Cool. It does not handle errors. So if we have a what do we do? Let's create like a list here, array list of integers, and we initialize it with self context allocator. Doesn't really matter. And then we try to we try specifically to append to this guy. 1, 2, 3. Right? I don't think this should compile now. No. It does not. And this is the thing that I expected to give me. Expected type void, but it found an error out of memory. So you can see that, like, okay, so append might throw like an out of memory error here. And this thing, because it doesn't have like the exclamation point there, it doesn't handle that because it is a void function. And why does it not have it? Well, because we're taking the address of that. We're using it here in an update callback. And you can handle errors in callbacks, obviously, but you can't handle them with just the exclamation point like this, with like an inferred error type, because that makes it like a generic function, which you can't easily take the address of. So I don't know exactly how this worked, how this built the stuff we did here. Let's try that again. Am I going crazy here? Server interaction manager tick. This is what we did, right? This should again not work. Not that it really matters, because I do, yeah. It does build, so that's strange. I don't think it should. But anyway, I know for a fact that this is called from the C++ side, so I want to handle the error there before we go into C++ land. Something is up with the cache. Just messed with it too much to have it work properly. Right, and now we're building again. Okay. Cool. Yeah, let's end the live stream in like 10 minutes. Then we've been going for a solid 2 hours. I think that's probably enough for today. I didn't get my vehicle switching working today, but I will for sure get that done tomorrow. And then we can move on to different things in the next live stream. It was a pretty good chat today about various things. Do you have any other questions? If we have anyone left, do you have any questions for me regarding SIG or the game or anything? Have a few minutes to take questions today still. Look at my notes here. Iterate over the client proxies is what we want to do here. So and actually we want to do like self on server, so if not on client, then we want to iterate the client proxies. And I think that is something that we can perhaps do today still. This thing is a slightly weird construct in the sense that this is essentially like a singleton, but it's like a client-server singleton. The client has one and the server has one, and they can talk to each other via RPCs. But it has this switch here in the init where you give it a host, which is of any type, so like essentially like a void pointer almost, except it's a compile time thing. And then we look at the host and try to figure out what it is. It can be a client pointer or it can be a server pointer. And it keeps like the host CPP pointer, which it gets out of the client somewhere. Right there. CPP pointer, right. Host is a thing though. It's sort of a hack. Host pointer. Because on the C++ side, the client and the server derives from host, but we don't really have any base classes in Zig. So I have some common functionality that I've gathered under this host pointer idea. It takes like a CPP pointer, C++ pointer, to either a client or a server, and it figures out what it is, and then you can call things on it. It's a bit of a hack, but it is essentially needed to emulate sort of virtual functions and inheritance in Zig. And so with this, what we actually want is to get the game session out of this. Because if we look at the interaction manager here, I'll go to the tick one. Server game session, we can get this out of the thing. We can get a vector of client proxies out of the server session, and then for each client proxy, so essentially every client that is connected to the game, we can update the interaction state, which is something that we need to do for the vehicle switching to work. We need to get this game session from somewhere, and I know for a fact that we can get it from the client and the server. Session, get game session, right here. And so maybe we'll add this to the host. Host.zig is right there. And we do that, and then we just call get game session on that, and that should be essentially everything we need to do, as far as I know. Then in the interaction manager, rather than keeping like this weird int pointer to a host, we can just keep a host ptr around, which is a slightly nicer wrapper around the C++ host pointer. So we just pass that directly like that. We might use it somewhere. Let's see if this now builds. Might not build. No. Pointless discard of function pointer or function parameter. That's a different thing. Expected type host pointer, found host client pointer. Okay, that's fine. We'll do basis host pointer init, and we give it the host like that. Then it figures out if it is a client or a server that we are passing it. Yep, that's better. And then out of this host, we can get the game session. So game session, self host get game session. And out of the game session, we can get the client count, first of all. And we can also get the client for each index. So let's do a for. What was the syntax? I think it's 0 point client count, and then like the index is I, like so, and this would be client proxy. Game session get client for I, right? Something like that. It wants to give that to me as a U size, and this expects a U32, so that's annoying. But we can convert that if need be. Yes, exactly. Well, we can probably just do int cast. And int cast should figure out by looking at the call site what it's getting and what it needs to be. Yeah, these are weird. It's like the return type is the inferred result type. So it sort of infers it based on whatever you are actually assigning it to, and then and then it converts it into what it needs to be. So it's strange, but it's kind of handy. Okay, and then the client proxy has a host ID, and we will call to do update the interaction target for the host ID. And that's something for me to do tomorrow, basically. Something like this. Okay. Cool. Let's see if the game still works. Nope. It does not work. What's going on? So CPP pointer is 0. That's not good. That means that the game session is 0 as well. Oh, yeah, I know what the problem is. The problem is that we don't have a game session yet. And that is why the C++ side actually had a flag here. What was the flag called? Something like game running or something. In game, yeah, in game is the thing. We don't want to just early out if we're not in the game. In game boolean. I'm gonna just set that to false, right? Yeah. And we set this to true here. And we set it to false here. Yeah, we don't have a game session object created immediately when the engine starts up. You need to actually like go into the game to get a game session. The game session knows about things like is this game a local game or a multiplayer game or something like that. So if we're not in game, then just return. And that should fix it for us. We can of course just print something here to make sure that we actually get player. This will just spam the host ID, but it's fine. Host client proxy host ID. Just make sure that we actually get this, and then I need to take that discard away. And I should spend some time tomorrow making sure that this Visual Studio Code setup is working properly. Right, so I should have player 1. Yay, I have player 1. Because the first player is always player 1. And there's only one here in this single player game. Alright, that still works. And that still works. So that's fine. Okay, cool. I will leave this here today. And I hope to see you guys in upcoming streams. What happened now? Oh, it's this thing again. Yeah, sometimes you get this like something is access denied inside the SIG cache. Then you just go remove SIG cache and then you build again. I don't know if it's like a SIG bug or something. But my SIG is a little old, so. yeah. Thank you for today. If you have any questions, now is the last chance to ask those questions in this live stream. Otherwise, you're gonna have to wait for the next one. Had some good discussion today. That's nice. All right. I think we're pretty much done. Have a good one. See you in the next stream or video. And bye.